Well, hello. Welcome to the OWASP DevSwap show. My name is Nancy. I co-lead the OWASP DevSwap project and produce this show. I'm here with my co-lead, Nikki. Hi, Nikki.
Hey, Nancy. Great to be here. So today is a very special show. Not only do we have a great guest and topic, but we also want to welcome 4 new team members to the OWASP DevSwap project.
Here's a short video.
Beck. Beck is a former security consultant and current application security engineer. On the side, Beck is a patchwork quilter of code snippets and infrastructure, a proponent of dopamine-driven development, and highly motivated to talk to you about security culture. James. James is a multidisciplinary engineer having experience in software engineering, DevOps, systems engineering, network engineering, and application and infrastructure security. On the side, James dabbles with hardware engineering and security research. Lily. Lily is a historian turned hacker with a penchant for security storytelling. When Lily isn't working to make the world a more secure place, she can be found serving on the board of Digital Rights Watch, educating people on privacy-related issues such as digital surveillance, and researching the history of various poisons. She is not a moth. Mimi. Mimi is a security engineer who specializes in cyber threat intelligence and a freelance illustration artist. She started her career in video game development and Japanese fashion before shifting to cybersecurity.
That's a great team, right?
Yeah, they look amazing. Yeah.
Yes. So without further ado, let's get this show started. And please welcome Beck, James, Lily, Mimi, Lily and Mimi. Sorry. Let's get started.
Hey everyone, as Nikki mentioned, we have a very special guest today. We have Shubham, and he's the co-founder and CTO of Assetnote, as well as a prolific bug bounty hunter in the top 50 hackers on HackerOne. He's presented at various industry events, including QCon London, Kiwicon, AusCert, BSides Canberra, and CrikeyCon. So can everyone please give a warm welcome to Shubs?
Hey everyone, thanks Beck. Today I'm going to be presenting on how to do code review the offensive security way, and hopefully this can be a little bit of a discussion between, the team and people in the comments as well. But essentially, when we are doing code review in an offensive security manner, often we start off with no source code. Often we're hacking something and we've identified a certain software that we want to look into further, but we don't have the source code. So one of the first problems that we face is obtaining the source code. And this is a really important part of the problem that I want to go through really quickly. When you want to obtain the source code, there are a couple of techniques that I want to run through. The first is cloud marketplaces. So in cloud marketplaces, often you can find source code listed there. So, we're fortunate to have many vendors list their software on marketplaces like AWS, Azure, and GCP. In most cases, trial licenses are available, which let us access that software. And it would be gated by an enterprise sales process. This is valuable because we can leverage these marketplace offerings to obtain the source code and then reverse engineer it and find vulnerabilities in it. I've used this technique a number of times, and even one of the times is demonstrated later in this presentation about how I was able to use this technique to get access to some source code. But yeah, cloud marketplaces, generally a great place to get access to source code that you typically wouldn't get access to. And as I mentioned earlier, this presentation is about doing it the offensive security way. So often you don't actually have access to the source code when you're looking at something from the offensive security lens. You might have just come across an asset on an attack surface. You might have just seen something running a particular software that you want to dig into further. So here's an example listing on the AWS marketplace. There was this software that was running on Facebook. So you can see the domain here is fb.com, and it was returning a banner called PCO IP Connection Manager. After I put that string into Google, looked around a little bit, I found that it actually referred to this software called Teradisi PCO IP Connection Manager. Now, from the offensive security lens, we want to be able to take this information that we've learned from this asset and then find the source code and then reverse engineer and audit that source code. So the fact that it was on the AWS marketplace made this relatively easy. I was able to spin up an instance on AWS with this software through the marketplace, extract the source code, which was a jar file, and then reverse engineer it and do source code analysis. Another technique is container image registries. So we're really fortunate that these days, the whole concept of Docker is now standardized and so many developers use Docker for so many things. The good news is that there is a central hub that people put their Docker images up on. So we can often use Docker Hub to find software that typically, again, is gated by some sort of enterprise sales process. There are usually images available for software that are typically enterprise software that you wouldn't be able to get very easily. That might be behind some paywall or some sort of registration process that's not easy for us to do as offensive security researchers. So you can find a lot of software on Docker Hub. So I recommend just hitting up hub.docker.com and searching for the software that you're looking for that you want to reverse engineer and looking for an image that has that software pre-built. It might not always be the latest version of that software, but it's probably close enough to get a good understanding of how it works internally. So here's a little meme, like I think a lot of the hackers that I know, they love hacking AEM, but one of the things that really sucks about hacking AEM is it's typically gated by this really lengthy sales process from Adobe. And you can't really get access to the source code without going through the sales process. But on the other hand, there's an image on Docker Hub that's readily available, and you can just pull it and start running it and start reverse engineering AEM at your own will. No sales process, no gates, nothing like that. It's very easy and straightforward. So yeah, I mean, just search it up on Docker Hub next time you come across some software that you want to look into. See if it's there first. The other thing that you can do is contact sales, and honestly, it's not the easiest thing to do because it's high friction. You have to get in contact with a real human being and see whether or not they're willing to give you a demo. This does have the highest friction involved, but if you can convince sales to give you a trial copy of the software, it's quite likely that you're going to be able to own the crap out of it. Often what I've found is when something is gated by a sales process so heavily and it's so difficult to get the software, often it's very likely that same software has a lot of vulnerabilities. This is my least favorite route to getting software because I don't really want to deal with salespeople. But historically speaking, it's had the highest rewards when it comes to finding critical vulnerabilities. And another option is freelancing websites. So here's an example where I've literally just gone on Fiverr and I've looked for someone who has experience in a certain enterprise technology, which was WebSphere commerce is what I was interested in. And I've just asked them, I've said, hey, do you have access to the source code? Can you give us a copy of that source code? I can pay you to set it up and so on and so forth. Now, whether or not this is against terms and conditions, that's a different story. But if you really do need access to some source code to audit it, this is an option. There are people on freelancing websites that are experienced in a certain suite of software, whether that's SAP, whether that's WebSphere, or anything like that, and they can often have access to the installation material. So it's probably something I'd say for the last resort, but it is an option when you need to get access to source code. And the last thing that I want to talk about when it comes to obtaining source code is chaining vulnerabilities. So you can often leverage other vulnerabilities to obtain source code for the application. So not knowing all the local file locations of the source code and potentially not allowed to do it in vendor and bug bounty programs, but local file disclosure is a common way to access source code from the underlying systems. Another example is using something like external entity injection to read local files as well and accessing source code that way. And also, obviously, if you have command execution, you can also read the source code. On .NET systems, one of the best things about them is that you can just access the .dll files, which are usually in the bin folder, and then reverse engineer them straight back to C# or .NET source code. So I do think that this is a valid technique to obtaining source code in offensive security situations. Your mileage may vary depending on if it's a bug bounty program or if it's something that you don't have access to exploit further. You don't have permission to do that. But for the most part, this is something that is a valid technique to getting access to source code in the offensive security mindset.
Chubbs, you mentioned contacting sales for source code. How successful have you been in taking that approach in the past?
Yeah, so personally, I haven't been super successful. It's something that I have tried to do. However, might just be because of the fact that I'm way too honest about being a security researcher and I don't look like a prospective customer. But I do have a friend of mine who recently he got access to some source code by contacting sales. And I think the key difference between his approach and mine was he made it seem as if he was an actual prospective customer that really wanted a trial. So the salespeople were quite keen to give him a trial and gave him access to the installation media. Once they did that, he reverse engineered that code and he found so many critical vulnerabilities, especially Java object deserialization. I know that it's definitely possible, and I know that when you're successful, it can often lead to critical vulnerabilities. But personally, myself, I haven't had too much success with it.
And you spoke a bit about the product teams and how they would work with the source code that they are giving out. How effective is it for product teams to do source code obfuscation?
I think that source code obfuscation isn't always the most effective mechanism to protecting the source code. I actually really appreciate companies and organizations that consider their source code to be public, as if there's no security risk if it was exposed, because I think that encourages the highest level of security maturity when it comes to source code analysis. There are techniques when it comes to obfuscating source code, like for example, in PHP, you can use IronCube. But all of these techniques that I've seen so far are usually easily subverted by some mechanism or another. Sometimes for IronCube, you can decrypt the software back to its original state. In other cases, it's often possible to decrypt it back to the current state as well. But while obfuscation is a valid technique, I think it will just increase the amount of time necessary for someone to be able to read the source code in its original form.
Yeah, it makes sense.
Cool. So I guess I'll continue. So the next section of this presentation is on source code analysis itself, especially in web applications on the server side, which is what I think is most interesting when looking at it from an offensive security mindset. So here's an example of some source code from Teradata PCO IP Manager. You know, that thing that I mentioned earlier in this presentation where I found a host on Facebook. So I downloaded the source code, I reverse engineered it, and I found this snippet of code. So this snippet of code is responsible for adding a new session. I wonder if people who are currently watching this have already identified the vulnerability. However, it might not be something that you can easily identify if you're not familiar with Java and some of the security considerations when writing secure Java code. So the line which basically says random.next bytes, that is the line of code that we're particularly interested in. So I'll just skip to the next slide. So just to clarify, this code here is generating a new session for this software, and it's using random.nextBytes. Random.nextBytes is actually referring to java.util.random instead of secure random. Due to this, sessions have an incredibly weak seed that can be determined, allowing an attacker to predict future session IDs. Can be of critical impact because attackers can generate valid future sessions by knowing the seed value. So Facebook paid $4,000 for this vulnerability because they were running a copy of Teradata PCO IP Manager on the internet. And they didn't know about this bug, they didn't know it was there. So the source code analysis really helped piece together something that, typically from a black box perspective, you wouldn't be able to find because you wouldn't really work out that it's using java.util.random. So here's one example of doing some source code analysis on a bug bounty target from a completely external perspective, from an offensive security lens, and coming up with a vulnerability that has real security impact and being paid out from a bug bounty program. Another example is this snippet of code. And I wonder if people who are watching have already identified the vulnerability here. But you can see that this snippet is basically a servlet which takes post requests. As a part of the post request, it reads the entire input stream, and it then parses that input stream, particularly parses the XML within that input stream. So some people may have already guessed what the vulnerability is here, because it's quite obvious when something is XML and it's being passed into an input and then it's being parsed. Often the vulnerability can be external entity injection. So we can see here the parse XML input functionality is simply passing that XML input into a SACS builder, and it's building a document out of the XML. There are no other mitigations in place that are preventing things like loading external entities, loading doc type, DTDs, loading anything like that. There are no protections in place. So the vulnerability here is external entity injection. And what that looks like is something like this. So this is technically, an undisclosed vulnerability that hasn't been disclosed for Teradata PCI IP manager until today. So this XXE is very simple. You post to this endpoint and you provide this input, and it would lead to external entity injection. Now, I think it's important to recognize that in this process, one of the hardest parts was just obtaining the source code. This vulnerability itself is not that complex. And in fact, a lot of the vulnerabilities that are discussed in this presentation aren't that complex. The tricky part is actually identifying what software they're running, grabbing the source code, and actually spending the time doing the source code analysis. So this XXE works pretty effectively. Sorry, go on.
I was going to say, Shubs, when looking for these kind of patterns, I think maybe people who are a little less familiar with offensive code review probably might not have the same kind of immediate reaction to certain functions being used and certain code paths being exercised. Are there any tools that you use that can help with this process for people who might not have the same sort of instinctual reaction to some of these bits of code?
Yeah, for sure. I think one thing that I really encourage, if anyone does do security research in their own time and just in general, is looking for a list of functions inside a language that may lead to dangerous behavior. So there is a tool on the internet called Grodded, which has a list of signatures for each different programming language for a list of functions that you should use for each vulnerability class. I do recommend that tool as a good starting point. I think that it's a great way to understand some of these vulnerability classes and what functions they may lead to. Another really great tool to use is semgrep. Semgrep comes with a default list of rules for all these different languages. They cover quite a few default languages, but that is also a really good tool to use as well, from my experience, at least for a base part, an initial run through of source code. Yeah.
Cool.
Shubs, we had someone in the comments ask about education and, if there are any particular degrees that deal with things like this, or maybe there are resources online that can help people pick up the skills to do this sort of reversing. Do you have any advice there?
My advice is typically is that you should go for a computer science degree if possible, and just become really competent as a developer and as a computer scientist. I think that often the security specific degrees can focus on things that aren't necessarily related to source code analysis, or they don't necessarily relate on offensive security too much. And I feel like if you are someone who has gone through the process of getting a computer science degree and has become a competent developer, you'll do a great job when it comes to learning about offensive security. And I think that those skills are really what are most valuable when you're doing things like source code analysis. I think that being a good developer, first and foremost, often helps a lot when it comes to analyzing other people's code.
Do you think that kind of plays into the idea that you've got to be proficient in what it is that you're reversing, right? So like if you want to know what you're looking for, you actually have to understand what it is that you're looking at to find the vulnerabilities. So it's almost like instead of taking a top-down approach and attacking it from a security angle first, you almost want to attack it from a developer's angle, if that makes sense. Yeah.
That makes a lot of sense. And I totally agree. I think even a lot of the times that I've been reverse engineering software, often I'm dealing with stacks that I'm not familiar with, like even Java and things like that. I haven't written much Java in my life, but it's taken quite some time to understand how everything works and fits in together. It honestly feels like sometimes I'm walking in the dark because I don't have enough knowledge about how certain things flow from point to point. And I think another link that will be shared as a part of this DevSlop thing is a link to a video from Live Overflow, where he goes through the concepts of sources and sinks. So he explains what a source is and what a sink is and why you need to identify sources and sinks to identify vulnerabilities in source code. When you're not too familiar with a programming stack and the languages used, it can be really difficult to find the sources and sinks. And that's often the case with every different language and framework. They all have a different way of defining the routes and a different way of executing the functionality. So you need to be familiar, at least at a base level, of how that works before you can start source code analysis.
Yeah. I also had another question around, you mentioned looking for different vulnerabilities, you would do things like look for certain strings and look for certain patterns in the code. Are there any lists that people can use to kind of, have somebody been there, done that, and basically provide a list of all of the things they should be grepping for? So maybe that's been open sourced somewhere or something like that?
Yeah, for sure. So the list that is provided by Graudit, Graudit, that has a good list of signatures for a bunch of different programming languages that can start you down the path of source code analysis. And I think it's a really great starting point. There still is work to be done on that project when it comes to certain vulnerability classes. But I think that's a great start. And I also think semgrep also has a lot of default rules that you can use. So you can just run semgrep across your projects and see what falls out, essentially. But as someone said to me earlier, last week, actually, they said semgrep is only as effective as the rules you write for it. So in many cases, you might actually need to write a bunch of rules yourself for your code base.
Yeah, awesome. Thank you so much.
No worries.
Shubs, you mentioned identifying sources and sinks and using tools like semgrep. Have you had any luck with newer tools like CodeQL in identifying some of these paths and taints and things like that?
Personally, I haven't had much success with using something like CodeQL, but I think that's mostly because of a lack of effort in trying to use CodeQL. I think that CodeQL can be really effective in many cases. However, I do think CodeQL is actually really something that it does take a lot of effort to write good CodeQL. And it's something that, if you've identified a certain vulnerability class that you want to squash, or you've identified something particular in your code that you want to search for and find all the sources and sinks, it can be really valuable. And I think that the value really increases when you've got really large enterprise code bases. So one of the code bases I was looking at earlier this year was Microsoft Office Web Apps, which is this huge enterprise project that when you revert, there's hundreds of DLL files. Once you reverse engineer that, it is an absolute nightmare to find the sources and sinks. And I think something like CodeQL could really be beneficial in that scenario.
Got another question from the chat, Shubs, about pair programming and whether you feel that there's benefit when doing code review to actually pairing with people, and whether you feel like pair programming actually can help, I suppose, avoid these kind of vulnerabilities as well. I think would be an interesting thing to talk about.
Yeah, I totally think pair programming helps. I think, in fact, every time that I've been doing source code analysis, I often share snippets of code with people that I think might have a better understanding of how it might work, or maybe they can help me understand it myself. That's been incredibly useful. I think there's been so many points in my source code analysis career that I've needed to ask other people on how certain things might work because I might not have a good idea. And also pair programming in general, I think one of the most enjoyable things about source code analysis is when you can do it with another person, because often you can cover different parts of the attack surface and you can come together to find really cool vulnerabilities. A lot of the experienced source code analysis, a lot of the more experienced source code analysis people that I know, they often have a really good understanding of certain technologies and certain things. So if you're looking at a really large attack surface, you might be able to combine your specialized skill sets in different different areas to be more effective at source code analysis.
I wanted to know also a bit more, like we've been focusing on, it feels like, more advice for developers trying to get into this, or that's sort of the vibe that I'm getting from the comments at least. But I wanted to know from your point of view, what your advice was for hackers trying to get into this kind of thing, if they are pivoting from a different kind of maybe offensive or defensive kind of point of view. And whether you feel that software development or having some dev experience actually makes you a better hacker.
Yeah, totally. So one thing I want to quickly clarify is, like, I know earlier I mentioned that computer science would be a good degree, but I myself am a university dropout. I've been self-learning all of this entire time, and my advice on this is just start digging and be curious about what you want to look into. I think that software development skills definitely do help you become a better hacker. But in many ways, you don't need to be the best software developer to start being a hacker. I think, like, there are many people I know in this industry that have started from the other way around, including myself. I got into offensive security before I got into software development. And that's something that, in many ways, it's a blessing and a curse. In many ways, when I write, because these days I do software development full time as a part of my role at the company I've co-founded, and often I find I'm brute forcing solutions all the time, but and that's not the best way of doing software development. But as a hacker, that is the most effective way. So yeah, I think that, look, like, you don't need a degree to get into this sort of stuff. I want to clarify that. I think that honestly, having a curious mindset and having a hacker mindset is probably the most important thing. You can self-learn all of this. You don't need to do a degree or a course or anything like that in order to learn all of this stuff. What I recommend is the next time you find software that you are interested in and want to reverse engineer, download something to reverse engineer it. So for Java, you can download JDGUI. For .NET, you can download ILSpy. Reverse engineer it to source code and start analyzing it, seeing if you can find vulnerabilities. There are a lot of really good resources like Pentester Lab, and a few others that help you through this journey.
I'd also add on to that, Shubs, speaking from my experience as well, which I think is very similar to yours, being someone who didn't finish university and then came at it from the software development and system engineering perspective at first. I found there was a lot of value supporting what you're saying about actually just getting my hands dirty and starting to contribute to some open source projects as a way to look at the kind of bugs that appear in codebases, because you end up handling sort of security flaws in those projects as well and learning about those patterns and how you can fix them. And I feel like that's really helped me with code review as well. Yeah,
for sure. Pattern recognition is like 90% of hacking, I think. But yeah, I'll continue on with my slides and we can get back to some questions in a little bit. So this XXE, no protections in place. It wasn't protecting from external entity expansion. You could use the FTP trick, which is a common technique when it comes to exploiting XXEs, especially in Java, in order to get directory listings and then files as well. So this TerraDC PCO IP manager, so this vulnerability has never been disclosed before, so you can write signatures on it if you'd like, but essentially it was hosted on Facebook's infrastructure, and this particular bug led to a bounty of $5.5 grand. So the next thing that I want to go through is this employment management system ZeroDay. So I can't disclose the vendor, unfortunately, because I've reported it to the bug bounty program. But this vendor in particular, they produce software that's used by a lot of companies to manage payslips and other employee-related data. The source code was obtained through a friend of mine. However, it's not something that was easily obtainable on the internet. I discovered this XSS ZeroDay through XML injection. However, I couldn't escalate it to external entity injection. That's just because of the nature of the bug, but we can go through that really quickly. So this is the first snippet of code. You can see that it's taking this parameter called Delphi GUID. And with this parameter, it's initializing a new system tree command, passing in this parameter as the second argument. So I think it's really important that when we review code, you can recognize the flow of information. So you can see here the source and the sink. And the sink itself looks something like this. So we've got a Delphi GUID parameter that's being passed into system tree command. And we can see that it is replacing some XML with our parameter. So you can see on the first line, XML.replace session ID with Delphi GUID. So essentially, we've got an input parameter that we can replace some contents of XML with. The thing is, I would have loved to get external entity injection here, but unfortunately, we are deep inside an XML file. We're not at the start of the XML file, and you can only declare doc types and entities at the start. So since we're halfway through the XML file, what can we do? Can we actually have it? Is there any security impact here? So it turns out there is. You can provide this parameter where you can provide this value where it's essentially a C data tag with arbitrary HTML. And thankfully, this endpoint returned a content type of text HTML. So ultimately, you can get reflected cross-site scripting through this vulnerability. Now, this is something that you probably wouldn't have found doing black box security testing. And this is something that this source code has really provided context as to how to exploit this. We know that we have a parameter that's inputting data within an XML file. What can we do with that? Can we get external entity injection? No, we can't. What else can we do? So this is ultimately the vulnerability that fell out of this particular source code. So this is another example of where you can apply your, offensive security mindset to source code analysis. Again, it does require a base understanding of, what are sources and sinks? How do I understand what a vulnerable function looks like? What are the vulnerable functions? And all of these things you can learn, by yourself by looking at some of the resources provided by companies like Pentester Labs and also other companies on the internet that have some of this information. Or you can just start getting your hands dirty and read some source code. Also, Googling for vulnerable functions, like dangerous functions, is also a really good idea. There's this amazing Stack Overflow thread on all the dangerous functions for PHP. And there's other threads on the internet that, all this information is out there for free. You can look at all these dangerous functions and start to understand what to look for in source code analysis. So I have two final slides, and they're mainly around what I'd recommend for people who are getting into source code review. One of the slides is for novice code reviewers, and the other is for experienced code reviewers. The first one is, when you're getting into source code review, you want to identify the sources and sinks. You want to make sure that you understand all of the places where source code is being, where input is being processed, where the data ends up being processed, so the sources and the sinks. You need to spend some time doing recon on the code base. So for example, identifying all of the routes. That includes looking at like if it's a Java application, that includes looking at the web.xml file, the application.xml file. If it's a Ruby on Rails application, looking at the routes.rb file. Understand all of these routes and understand where they lead to on the server-side functionality. Make a note of all of these inputs and make a note of all of these routes. Be as thorough as possible. It's totally worth it. It's worth the time being thorough here because you will miss attack service if you're not thorough. And go through a server-side flow from the HTTP request to the point in the code where it's being processed. Repeat this for all the different parts of the application so that you can map out the attack surface as best as possible. This will put you in the best position to identify vulnerabilities because you will know all of the HTTP requests and which controllers or server-side functionality it leads to. So this is my advice for novice code reviewers that are just getting into it. This is what I recommend. This is what I think are the couple of steps you can take to really start getting into source code review. And my last slide is around for the more experienced code reviewers, because I recognize there might be people that are watching this that have been doing source code review for some time, and maybe this is just reaffirming some of their beliefs, but this is what I think more experienced code reviewers should be doing. I think that one thing that's really important is the interoperation within the software. So how different components rely on each other and how different components interact with each other. That exposes a whole new layer of attack surface that you need to understand and you need to reverse engineer so that you can find vulnerabilities in. Another thing that you can be really successful with is understanding the dependencies of a project. So some projects have all sorts of different dependencies. Like for example, if you want to resize an image, you might have to use image magic for that. And that is an external dependency and it is being called in some way or form. So sometimes you might need to get your hands dirty and fuzz these binaries and start understanding, all right, can I exploit some of these dependencies in some way or form? Often exploiting dependencies can lead to critical vulnerabilities as well. Another thing is don't make assumptions. Even for standard libraries, you want to read the documentation and you want to fully understand how that functionality is being provided. I think that often us as humans, and we do it all the time, we can make assumptions. And when we make assumptions, we can often forget critical parts of information that may lead to vulnerabilities. So even for standard libraries, don't make assumptions, trust but verify all of the things that are happening. And another thing is make sure you're covering all the attack surface. So all the internally and externally exposed ports, protocols, and services when considering attack chains. So for example, if you have a server-side request forgery vulnerability, you want to make sure that you can escalate it or you want to try and escalate it. So you have to account for the other components being exposed within the software. So the internally and externally exposed ports, the protocols, the services that may be affected through something like a server-side request forgery vulnerability. And also making an effort towards chaining vulnerabilities for impact. So if there's a whitelist for SSRF, don't stop there. Like try and attempt to exploit the whitelisted endpoints, for example, finding an open redirect to achieve an unbounded SSRF. This is something that I've been successful with in the last couple of months. I found enterprise software that has restricted the server-side request forgery to be just one URL, but using open redirects, I've been able to bypass that restriction and get access to arbitrary URLs through the server-side request forgery. And lastly, try and gain a deep understanding about the application on its stack. So this is something that Mimi was talking about earlier. If you understand the stack really well, then you will have a better understanding about how to reverse engineer the source code and find vulnerabilities in it. Each framework and application can have its quirks, and you've got to be conscious of that before auditing it. But that's all I have today for my part. So I'll be happy to answer any questions from the team.
That was awesome.
Nice
Thank you,
Shubs.
Shubs.
And the chat is popping off, so we've got a few questions.
Yeah, quite a few.
Very good.
To kick off this round of questions, because I know we have quite a lot to talk about, part of the point of this is obviously that we're talking about manual code review and the kinds of stuff you can find doing that. I can see some people in the chat talking about open source stuff as well, things like using Zap and piping that into a CI/CD thing to try and automate this kind of source code analysis. Do you see value in doing that? And what kind of value do you think that could provide versus manual review?
Yeah, for sure. I do see value in doing that. And I think there are quite a few tools that let you do things like that. Like SonarQube, for example, is another example where you can pipe your source code through it and put it through a CI/CD process and see what falls out. There is benefit to doing that. However, I will say that a lot of the vulnerabilities that I've been finding in source code review over the last 6 months, it's been often things that wouldn't be picked up by automated tools. Some of the vulnerabilities that I identified in this presentation might have been picked up by automated tools, but some of the stuff that I've been working on the side, which hasn't been related to the stuff in this presentation, often these vulnerabilities are to do with configs that have gone wrong and things that tools won't be able to recognize. So I think the manual component is still really important, but yes, automated stuff can help to some extent.
Going back, Shubs, you mentioned the XXE couldn't be exploited because you weren't at the start of the document. Is there any way it would be possible, like if you were looking at chaining exploits, to find almost like an injection where you can basically trick the parser into going, oh, look, a new XML document, let me just go off and process that instead?
I would have really loved that. If it was possible, that would have been an amazing exploit. One of the things that is tricky about that particular example that I showed was that the doc type declaration has to happen at the top of the document. And if it doesn't, even if another document was including this document, the doc type declaration wouldn't be at the top of the document. So we wouldn't be able, at least in the parser that I was working with, which is a .NET parser, it wasn't possible. But it's not to say that it's not possible in other parsers. Like maybe in Java, some of the different XML parsers could treat this behavior differently, and it would be possible there. But with this .NET parser, it was incredibly strict about where the doc type needs to be. There might be something still there, and if there is anyone that has any ideas on potentially exploiting it further, I'd love to hear about it. But I wasn't able to get it anywhere further than just the XSS, unfortunately.
Yeah, no, that makes a lot of sense. We also have some other questions around sort of threat modeling. Have you ever had any benefit in creating your own data flow diagrams or creating threat models to help you understand sort of what you're looking at?
Yeah, for sure. More from the defense side, to be honest. So the work that I do at the company I've co-founded at Assetnote, often we have to think about some of the security considerations because we're developing this huge code base at this point. What I've found to be the most effective mechanism is always thinking about it like an onion, where it's like layers of security, and piling onto that layers of security as much as possible. The threat modeling component is incredibly important. And it is something that we often think about when we develop software in a secure manner is, okay, what would happen if this security protection stopped working? What would happen if they bypassed X and Y? Would we still be secure? Is there something we could do to make it even more difficult for an attacker to potentially bypass these protections?
Yeah, awesome. And I think like in that same vein, we've got a question from the chat. Can you speak to the importance of context? So a human code reviewer keeping all the moving parts in their head versus automated analysis, which is not able to do the same. So where do you see the value in both working together?
Yeah, that's a really interesting question. I think that a lot of the low-hanging fruit can be identified by automated source code analysis. And I think that when it comes to like one of the big problems I have with automated source code analysis is it just like the question is mentioning, it doesn't have the context. And that context is critical sometimes when it comes to vulnerabilities. And it's not as if we're not at a point where we can teach these automated tools that context. We're getting better at it. Like CodeQL is a good step in the right direction, where we're really trying to understand the flow of information in a code base from beginning to end, and trying to map that out and find vulnerabilities. But there are just cases that, at least in my career and in the time that I've spent source code auditing, that you can't really get the same results from an automated source code analysis tool. And I don't really have many solutions for that. I mean, the best thing I can think of is trying to educate that automated source code analysis tool about every route that there is. Trying to feed in data, making it a little bit less black box for that source code analysis tool. Trying to provide as much context as possible to the source code analysis tool. And I think there are certain technologies that let you do some of this these days, but I don't have as much experience in automated source code analysis, so I wouldn't be able to speak too much about it.
This sort of leads into some questions I saw flying by in the chat before about, and also to our conversation a bit earlier about pair programming and how that helps catch it. But do you think that tools like, say, GitHub's Copilot are going to be useful for this kind of thing? I know that Copilot can be a bit of a spicy topic, so I kind of wanted to know what you thought about Copilot as a way of pair programming, catching kinds of malicious patterns or, you know, vulnerable patterns, and what you think about it.
Yeah, sure. I'm not sure what the impact of Codepilot will be on source code analysis, but I do think that it could be likely that code that is insecure is going to be provided by Codepilot at some stage, because I don't think Codepilot has context either about what is secure and what is not. I've seen some examples from Codepilot where, you know, it's produced code that's trivially vulnerable to SQL injection, for example, for PHP. And I don't think that Codepilot is going to be a solution when it comes to writing secure code, because I don't think it knows what secure code is either.
That makes a lot of sense. We did have another question just to sort of redirect here. How much time are you normally spending on these research projects? And, you know, do you use fuzzing? What other things are you doing to help you find these exploits?
Yeah, sure. So it depends on how big the source code base is, how big the application is. For some of the larger enterprise applications, like, for example, Microsoft Office web apps, I probably spent a few months there, like 2 months. For some software that I've been looking at, like WebSphere, for example, I've spent something like a couple of months on that now as well. However, like when I say a couple of months, I don't mean that I'm working on it every day. Probably every weekend. So every weekend I have the opportunity on doing the source code analysis and finding some good bugs there. But yeah, I do spend a lot of time on source code analysis, because one of the things that I think is really valuable when it comes to applying it from an offensive security mindset is, once you find a vulnerability in a popular software, you can apply it on all the bug bounty programs that exist that are running that software. You can rake and cache that way too. So sometimes the months of effort is actually worth the amount of time because of the money you can make from there. And when it comes to you know, what other processes I'm using to do this source code analysis, I'm going through the typical flow of running it through tools like Groudit and running it through tools like SemGrep. I have only recently started creating custom SemGrep rules. That's still something that I need to do more of. I haven't started using things like CodeQL yet. I do think that it would be valuable to start using tools like that. However, I haven't started doing that yet.
A related question, Shubs, from the chat was, how much time do you tend to spend? I guess a further question is, you know, like, is there a cutoff at which point you lose interest when you're setting up test environments and, like, I suppose, environments to scan for and test out bugs that you think you may have found on these kind of like enterprise code bases when you do get a copy of the code?
That's an amazing question. I actually think that one of the hardest things in this whole process is setting up the enterprise software. Like that is one of the most difficult things. Like for when I was testing Microsoft Office web app server, I had to basically become a domain admin of a forest on Windows in order to set up Microsoft web app server. So I might as well have gotten a certification from Microsoft for setting up domains in a forest, because that's what was required just to get the software off the ground. And that was like, that took 2-3 days of my time just to get from nothing to setting up the software.
Accidentally Microsoft certified system engineer now.
Accidentally, yeah. And that's a big investment, right? Like, I think almost sometimes it's weirdly encouraging, because I know that if something is so difficult to set up, no one has looked at it in depth. And weirdly, I know that if something is really difficult to set up, there's likely going to be vulnerabilities in there. So it's an unfortunate thing that you often have to spend time in, but it's not the worst thing because it indicates that there could be issues there.
Right. The road less traveled, right?
Yeah.
It's like one of those things when you're playing a video game and it's like the more enemies you reach, the more obstacles, you know the good treasure is that way.
That's where the loot is.
Yeah.
I have a question on that vein, Shubs. Like, have you had any, do you see any benefit in using tools like Terraform and things like that to help automate some of those setup steps? Like, have you had any luck looking into those processes?
Yeah, for sure. I mean, if you're proficient in something like Terraform or Ansible or any of the tools that you can use to set up these things in a reproducible manner, it would definitely save a lot of time. Like, for example, the Office web app server, I've had to set it up maybe 5 times now. And each time I've gotten better at becoming a domain admin. But at the same time, I probably shouldn't have had to do it manually if I could have just done it in an automated manner the first time around.
And on a different tack, I've just seen a pretty good question in the chat about code obfuscation. I know we touched on it a bit earlier, but we haven't really gone into depth about what code obfuscation actually is and the barriers that it presents to analysts. So could you, the person's here asking, does code obfuscation offer minimal value to the authors regarding ease of decompiling? Can you talk a bit about like what obstacles code obfuscation puts in place and why that is or isn't a useful thing to be doing if you're a developer?
Yeah, for sure. Yeah. Sometimes code obfuscation can be done in an effective enough manner that it really adds a huge barrier to people doing source code analysis. There was an example. So I was auditing a software called Plesk, and Plesk had written this obfuscator in a custom manner. It was a version of IronCube that was written in their own format, or similar to IronCube, and it was calling a binary on Plesk itself to do the compiling of code in real time from the obfuscated version to the deobfuscated version. So to reverse engineer that would have been a lot more effort in understanding how that binary worked on the local system and reverse engineering it enough to try and work out what the original source code was. So in that scenario, it was effective. It stopped me from initially, I guess, testing that software because I knew the time that would be required to reverse engineer it would be something that I wasn't willing to put in. So some scenarios, obfuscation does make sense, but the scenarios where I think it actually doesn't make a lot of sense is when you're using something like out of the box, something like IronCube, where IronCube does have a lot of different decompilers out there on the internet that you can pay something like $15 and start getting all this PHP code decompiled.
Awesome, thanks. Do we have any other questions coming through that we might want to answer in our final few minutes?
There's one here that I think would be good to ask. How do you approach Shubs doing all of this in a language that you're not familiar with? So say for the first time you hit Java?
Yeah, that's a good question. And it's actually happened quite a few times. The first thing I do is I read about how to develop a basic application in that language. So how do you define the routes and how do you define the controllers? Probably the most important part. Once you've identified how to do that, you see if you can find the same sort of patterns within the code base that you're auditing. So hopefully you can identify the file which defines the routes or the way that routes are defined and the server-side functionality in the backend that that these routes lead to. Once you've identified that, the next thing I look for is I try and do some searching on the internet for dangerous functions for that language, or I look at the documentation for the standard libraries in that language to see what functions could be dangerous. So for example, one of the things that I had to audit a while back was this weird language called AmpScript. And AmpScript is like this Salesforce exact target email marketing language. And I had no familiarity. I was not familiar with it at all. So I just spent a lot of time reading through the documentation of that language to understand how I could exploit it. It's the same thing when you're looking at code bases that you've never seen before. Half of it is just a journey in reading documentation and understanding how all these different pieces are working together. I know that this is pretty basic advice, but it is what I found most effective when it comes to looking at code bases that I don't have much familiarity with.
It's interesting too, just really quick aside before we get on to the, I think, final questions and wrap up. You mentioned the routes and that strategy, I guess, probably helps you because I guess a lot of these code bases that you'd be auditing would be quite large enterprise software, right? Like there's a lot of code and like getting started would be really difficult too, right? So like focusing on the route sounds like a really solid strategy, if you're dealing with like something that has an API.
Yeah, the routes are really important, but sometimes what's really difficult is there are languages which have really complex ways of exposing attack surface. And that's where it gets really difficult because you need to have a deeper understanding of the language and how certain things work. Like, in Python, there's the concept of decorators and how decorators can lead to certain functionalities, and there's dependencies that may have decorators and things like that. So you might have to really dig deep to understand where all the routes are. In Java, there's also similar functionalities in like Spring, for example. You can define different controllers and routes in different ways, whereas they don't have to necessarily be defined in the web.xml file. So like it's really hard to be on top of the routes because each language and framework seems to have a different way of defining them. And I think that often requires a lot of effort to map out the routes, but that's probably the most important part, in my opinion.
Yeah, no, that makes a lot of sense. It looks like there aren't any more questions that we haven't already answered. So I guess thanks so much for being on the show, Shubs. Thanks for sharing what you know about code review and how to sort of do that to drive offensive security. Just for our audience, our next OWASP Dev Slot show is going to be on fuzzing, DevOps, and you, getting to know fuzzing with Alison from Portland State University. Depending on your time zones, that could be Friday, that could be Sunday. So just check out the meetup page for the accurate time in your time zone. And then in September, we'll have Alex from Afterpay talking about software security at a rocket ship pace. We hope that you'll join us for those 2 sessions, and we'll see you all then.
Thanks so much, everyone.
Yeah, thank you.
Thanks, everyone.